I'm not a marketing guy.
All right.
Yes,
Okay.
so this is the machine where we machine everything. We have about 15 CNC machines. We have most of them are turning machines. We have 2 milling machines that are the same size and the same brand, but one is newer. So milling is the lesser part of the production. So turning is the bigger part. That's how we started. In 1983 we started. My father started the company. Yeah, my father started the company. Yeah, and he started together with a friend. And after about 1 year, he wasn't working. So he's been working at this. It's 85, I think it is, officially. So he's been a long time in the business. I started here working full time in 1994. So I've been here quite long too. And started to work on the floor, producing things, both of us. And then we progressed in the company. So now when we started the company, we had only Swiss turning. The form of turning where we have we put the bar through I don't know what it's called, but
Do you mean like rollers?
no, hylsa.
Okay.
Through a collet, you can call it, and that means you work really close to the collet and you can push the material through, so you can turn really long thing through. So today we can work with materials from approximately 1 millimeter up to 300. It's the size in the turning, and milling it's about
500 millimeters.
500 millimeters.
Yeah.
So everything I only talk in millimeters.
Yeah. Yeah.
So
can you show us some of the capabilities that you can do, the type of mechanical part? I mean, I assume you can do anything.
yeah, almost.
Yeah.
Not everything. We only have a cutting technology, so we don't work with sheets of metal.
Right.
Like bending and cutting and stuff like that.
So anything that can be milled.
Yeah.
So you can cut metal, but that's milling basically.
Yeah, milling and turning.
Yeah.
Yeah.
Okay.
That's the two. That's what we do. We have companies that we work together with that do that kind of products. So.
But what is the precision you can achieve with metal parts?
We have one metal part that we produce in 10,000s at a time, and we have.
Precision, I mean.
Yeah.
10,000th of a millimeter, you mean?
No, 10,000 pieces, and we have the tolerance is plus minus 5,000 of a millimeter.
Plus minus 5,000.
Yeah.
Yeah.
In
Okay.
the diameter.
Yeah.
So that's what we can achieve in some of the machines. It depends on which machine and which size and everything.
Yeah.
Because if you go up in size, this one is I think it's a 4 millimeter axle.
Yeah.
And if you go up in size, then you start to have problems like, well, it's a sunny day, it's warm, then it goes up in diameter, and it goes down if it's cold.
Yeah.
So you have to have the temperature all right when you measure it. If you have these small, and it depends on the material too, how much. Things, and that's the scanning probe. It's up there now.
Right.
And then you have the obstacle. You can't see it right now, but and then you have a laser probe also that goes down, so you can measure surfaces. And you can use it as the probe, basically.
Yeah. So you can guarantee the precision that you manufacture.
We make a program for it, and then it goes around measuring everything.
Yeah.
So when you first time you have to make a program.
Yeah.
So the machine knows what to do.
So you program it to basically the profile that it has to follow, and then it tries to automatically adjust the needle so that it doesn't catch up into different. Okay.
You know so you have to program it like in a coordinate system.
Yeah.
This is where you want.
Exactly.
And we can use files, so we can take a file from that piece that's up there and put it in the machine and convert it into a program.
Yeah.
So the machine knows, and then you have to put in all the tolerances for all the measurements.
Yeah.
And then you get a report afterwards, and then you see like all the red numbers are outside of the tolerance.
Right.
The green ones are in. That's basically how.
So is this something that you do on all of your parts that you produce before you deliver them, or only on request?
No, only if you want all of the parts measured. That's very expensive.
Right.
So we do, before we start any production, we do a first piece control.
Right.
The machine operator, he or she takes the drawing and starts to set up the machine. And when they think, now I have a piece that looks and feels and are like the drawing with all the tolerances right and everything, they come in here and they put it here. And Rovan, who's our politician.
Okay.
Quality technician.
A quality assurance.
Quality. Yeah. He's basically in charge of this room.
Yeah.
He checks it, all the measurements, and writes it on the drawing that he has checked it. And then he says, well, you have to fix this. This is not good, or it's all good. You can start producing.
So what are some of the reasons that things may turn out wrong in the production? Like when you design a part in CAD, like I assume that there are certain cases where when you produce it, it results in lower precision because you design it wrong. So what are the common faults that are?
Common faults. Do you have a day and I'll explain it?
Okay, it takes a day. All right.
You can say it's very, very different, and it depends on what material it is and how many you're going to produce and which machine it is and everything. But mostly breakage of the cutting tools.
Right.
That's one of the things. And we produce some things in stainless steel, and there is one kind of stainless steel that are, I don't know what's called in English, but syrafast in Swedish, that's like
acid resistant.
Acid resistant.
Yeah, it's very hard.
Yeah, it's very hard.
Yeah.
And you can't. That's very. It wears a lot on the tools, so they break quite easy. And even the tear and wear of the tool depends. It affects the pieces.
I see. So it's as you produce the tool, as you produce the piece, if it's a material like that kind of steel, then the tool actually degrades, and that creates faults in the. Right. Okay.
And that's why you have to have the machine operator have to check the pieces with different intervals.
Yeah.
And that is something today that we have. It sounds a bit. Well, the machine operator thinks, well, I know this material. I have to check it this and this much.
Yeah.
Depends on it's the machine operator.
It's the experience that they
that tells him how often he needs to check. We do have protocols for checking from our customers sometimes, and then it says you have to check this measurement one time each 5 or 10 or 50 pieces, depending on how accurate you want it to be.
Yeah.
Do you work with titanium?
Yeah. We've been working quite a lot with titanium in the past. Now we only use it to produce, I think it's 1 or 2 pieces. Yeah.
Do you have a suggestion for a?
Titanium.
Do you have a suggestion for a similar material to titanium, which has similar properties, but which like light and strong?
No, not really. I think it's some kind of aluminium in that case, but that's not comparable to titanium. Titanium is a very hard material to work with. It's not this piece that we have here. That's something we have talked to them. We produced it for several years, and we said all the time, change the material.
Right.
It's not nice. And now I have to change the price for the piece. I have to double the price because then titanium has gone up, and they made some changes to the drawing where the tolerances were much more sharper. So we had to double the price per piece.
Yeah.
Because we can't keep the price down when it's titanium.
What about Inconel?
That's all right.
Inconel.
Inconel, not very much. We try to avoid it. It's very hard to work with. Yeah. So titanium is one of the harder materials we work with. And the problem with titanium is that you have the possibility that it's not to burn. It's it catch fire quite easily. So it's
Surprising. I had no idea.
yeah. So that's something we are very afraid of when we produce. So you can't. We try to some pieces when there are a lot of pieces. We try to let the machine work by itself. So in the night when we go home, the machines are still working when we go home. And there's no one to check them until the day after. But you can't do that with titanium because it catches fire and the whole thing burns down.
It's the sparks that.
No, it's the heat. Because titanium is. When you work with titanium, it has very high friction.
Yeah.
And it tears a lot to the tools. And when it starts tearing, it goes very fast. So sometimes you can use, for example, a drill, and it starts to be not that sharp from the beginning, and you can still use it. But when you use titanium, it takes maybe 1 or 2 pieces, and then it breaks. And then the machine tries to go in and drill, and it's like when you make fire with sticks, like this.
Yeah.
That's the same thing.
Right.
The friction starts building up, and then it starts to burn.
So do you mean that it actually catches fire for real?
Yeah.
It just spontaneous combustion and then it continues to burn?
You have to have heat to it. So it doesn't stop burning by itself.
But if it gets hot enough, it starts burning and then it doesn't stop.
Magnesium?
Yeah.
It's the same thing.
All right.
Yeah.
Okay. That's
It
good to know.
burns with a bright spark.
Yeah, I've seen titanium sparks, but I didn't actually know that it would burn if you drill it and it gets hot enough and then it doesn't stop burning once you stop. Yeah.
It burns even more. We had actually we had one fire here for I think it was last year it was in one of the machines because you can but we can't turn those titanium in Swiss machines.
Right.
Because the collets, it's so high friction. When you pull it back, the collet goes back, and it's like a cone, like this. And when you pull it back, it clamps around the material, so the material gets stuck. Because when that's when I'm going to explain.
Yes,
you pull it forward and back, and then it gets stuck, and then the tool coming down, and they think that the material is inside, but it isn't. It stays up, and then it hits the material.
Right.
And last year we had one of those where the material wasn't pulled back, and the drill came down, it started drilling, and it hit the material first, and the drill bit got torn, and it started drilling, and it started burning.
Oh, okay.
Oh, mental.
Yeah.
All right.
So that's not. So that's why we don't. So you can produce quite a lot of pieces, and you can produce different kind of pieces on every pallet and on each side if you like. But the memory capability in the machine is too low, so you can't do that.
Oh, really? I was wondering about that. Alloys, plastic.
Yeah, everything, basically. And then sometimes we, like in Cornell, we haven't the experience. We can try, but so it takes approximately, depends on the machine, but we have a standard where we start. That's 4 hours because
Right.
until you get the first piece
Right.
in these machines.
Right.
It takes about 4 hours to set the machine,
Yeah.
and then maybe it takes 5 minutes to produce one piece. So
Right.
it takes 4 hours and 5 minutes.
Yeah.
So that's, and then if you produce many pieces, then
Yeah.
it's only 5 minutes that goes. So the production time is depending on how many pieces you want and how hard the setting of the machine is.
Yeah.
And that's something we appreciate from the beginning. Maybe we calculate with the operators and we use them a lot and talk with them and how do you think this piece. So we always involve the person who's going to produce the piece.
Yeah.
Because they maybe think of something that we don't, and before we calculate price and send it back.
Yeah.
Yeah, so that's good for us and that's good for you.
Yes.
Because
So-
then we get the biggest one we have. It uses, you can turn about 300 millimeters at maximum.
Okej. Alltså, det är en svarv?
Ja.
Ja.
Jag stänger av. Unfortunately, it has broke down right now. So we have a faulty, well, it's lying there on the floor.
Ja, the belt.
It's a conveyor belt that's gonna make the pieces come out in this end. But we have to change the belt in our history. And this is how it looks. Today we are just manufacturing an easy kind of piece. You have 3 revolvers with 3 axes in all. You have Z, X, and Y. So you can move.
So this is fully 3D.
Yeah.
This is awesome.
No, we lack one to have it fully 3D.
Oh yeah, of course.
You have to be
The
accurate.
perpendicular, yeah.
You have to this one.
Right.
So you have to be able to turn this one like this. That's
Yeah.
why we have these. So you can drill a hole diagonally into the piece.
Yeah.
But we only have one of these because they are so expensive. One of these is 50,000 crowns.
Okay.
So you have to have a lot of jobs that uses them
Yeah.
to be able to. And all places on the revolvers have rhythm tools for this turn. So you can drill a hole, not just in the center, but you can go outside, and you can mill in this machine also.
Okay.
And you have see,
So this is fully milled on this
this-
side.
Yeah.